Okay, so this question comes from the pre-calc class, and it's about depreciation, all right? So let's say we have a piece of equipment or something that costs $35,000. Its value today is $35,000. We want to depreciate it over a period of 10 years. We want to evaluate this depreciation monthly, so 10 years is 120 months. We're going to use monthly depreciation here. And after 10 years, 120 months, its value is going to be 0, okay? So we're going to use a linear depreciation, so we're going to use our good friend, the linear equation, right? So y equals mx plus b. M is the slope, right? And we know that the slope is defined as y2 minus y1 over x2 minus x1. Those are minuses, not dots. Okay, so in order to get these points, let's look at this thing from a practical perspective. We look at time in months, right? And we're looking at its value, okay? These are kind of what we're going to use to replace x and y. So when the time is 0, the value is 35,000. That's what we said, yes? And when the time is 120 months, its value is 0. This is just a statement of the problem, all right? So these 2 points represent the statement of the problem. So this linear function has to agree with these 2 points. So let's pick one. It's got smaller numbers. It doesn't matter. You can pick either one. Right? And let's go ahead and use this point as our plug-in point. First, we have to get the slope. So slope is y2 minus y1. I named this one 1, this one 2. So, there are some folks that have difficulty with the slope formula. I typically don't do it like this. I should do it the way I do it, okay? The way I do slope, all right, is I use a couple of parentheses. And then I label them. y2, y1, x2, x1. Because sometimes the things that you plug in here, they're negative, or sometimes they might have, they might be functions, or who knows what they are, okay? And so this structure helps me. It's kind of like a form, like when you go to an office someplace, the doctor, they don't give you a blank sheet of paper and say, here, tell us about yourself, right? They give you a form, right? It has blanks. It's just the information that they want, organized in the way they want it. So I kind of use this as a form. It makes it easier for me. So, y2, I can come here to 2. y2, that's 0. I just plug that right in, right? y1, 35,000. If it's negative or whatever, it doesn't matter. x2 is 120. And then x1 is 0. Now I can do this with no chance or significantly less chance of error. This is what your slope ends up being, okay? And then you just plug this stuff in. Then we're going to use point number 2 again. Y is 0, x is 120 for b and t. And we solve this and we get that b has to be 35,000. We can test it with any of our points, and we'll see, we can test it with this one. If you put in 120 here, the 120s cancel, you get negative 35,000 plus 35,000, which is 0. It has to work for both points, and it has to be linear, okay? So this is linear depreciation, fairly straightforward. If you have any questions about it, let me know, and we'll do another one. Or if you have a specific question, we'll address it. Okay?